Hello, my name is Beth Dixon, and I am the Math Lab Coordinator here at Walter State Community College on the Morristown campus. And I work in MBSS 222, that is in the Math and Behavioral Social Science building. It is my job to help students with their math courses here at Walter State. And as that, I'm going to do a lesson today on division of fractions. And I want to start out with the division of whole numbers that we know the answer to, which is 20 divided by 5 is equal to 4. And the reason why I'm starting out with that problem is one of the issues that students have with dividing fractions is that they really don't know why dividing fractions work, why they get the answers that they do. They just kind of do the steps and they're not sure why those steps work. And I want to kind of give a reason why on this first example. Um, and then that way you've kind of got a basis of why we do what we do so that it's a little easier to remember and so that we've kind of got something to hang our hat on, as I call it. What I would like for you to look at, first of all, is this 20 divided by 5, and I've got 20 little pieces here. So they represent 21s or 20. And I want to divide these 20 things by 5. Well, one way of looking at 20 divided by 5 or as a concept or as division as a concept is how many groups of 5 or how many size 5 things are there in this 20. So if I look at this and I take, here's one group of 5, here's a second group of 5. Apparently I can't count. Here's a third group of 5. And of course, here's the fourth group of 5. And so we have 20 things, and how many groups of 5 can we make? 1, 2, 3, 4. So 20 divided into groups of 5 give me 4. Or how many size 5 groups can we make? Now, let's look. And I'm using the wrong sheet, so excuse me while I switch sheets. I want to do this example. See, it has the same first problem, but the second problem is different, so I'm switching out. And this time I'm going to look at how to do it with a fraction. 1/2 divided by 1/6. So I'm going to use these Cuisinart rods, and to start out with, we want to start out with this green one. This dark green one here is representing our 1. So that's 1 whole. So this right here, the light green one, represents our half pieces. So 1/2. So this right here, this green piece right here, represents the half that we have right here, because it takes 2 of those to make a whole. And I'm going to get another one here so you can kind of keep track of that. And if I bring these in, it's going to take 1, 2, 3, 4, 5, 6 of these little pieces to make the whole. Okay, so this right here represents 1/6. So just like I wanted to say how many groups of 5 did I have in 20, or how many times can I, how many size 5s do I fit into the 20, I want to know how many size 6s I can fit into this 1/2. Well, there's 1, there's 2, and there's 3. If I take this half and divide it into 1/6 size, how many 1/6 do I have? There's a 6, there's a 6, and there's a 6. That's a size 1/6, that's a size 1/6 group, that's a size 1/6 group. So how many groups do I have? I have 3 groups of size 1/6. So 1/2 divided into 1/6 size is 3. Now, let's prove that using our algorithm for division. How do we divide fractions? We take 1/2, and remember the rule for dividing fractions is we take our division and change our division to a multiplication, and we take 6 and take the reciprocal. We flip this second fraction. Now, you're not always going to write that arrow there. That's just for emphasis here. But we're going to flip that fraction to 6/1. Now, at this point, we can either just multiply through or we can reduce. We'll reduce later. Right now, I'm working on a concept. So 6 times 1 is 6. 2 times 1 is 2. 6 divided by 2, lo and behold, gives me that 3, which if I have a half size, it's divided into thirds. And again, we know that because of, there's my whole. It's made up of 2 halves, and the little brown pieces or tan pieces are 6 size. So it takes up 6 of those. So those are the 6, and 1/2 divided into 6 size means we have 3 of those. Okay, let's look at another quick example here, and that would be 1/2 divided into 1/3 sizes. And I'm going to pull out the 1/3. I'm going to still use the Cuisinart bars, and there's my 1/3 pieces. And I'm going to get rid of all of this, set it over here to the side. There's my 1/2. Step over here. Prove it's a third. I need 3 of these. So that's 3 to make up that whole. So I want to know how many 1/3s it takes in this. Well, it takes 1, but 2's too many. See that? Well, it looks like it takes 1 and then half of another. Do you see that? It looks like it takes 1 1/2. Well, let's follow the rubric of what we do. To divide a fraction, we write the first fraction as it is. We change the division to a multiplication. 1/3, we take the reciprocal. We flip the fraction, put a 3/1. Then we multiply following the rules for multiplying fractions. 3 times 1 is 3. 2 times 1 is 2. 3 halves. Well, now wait a minute. I said that was 1 whole and half of another. Well, 2 goes into 3 one time with 1 left over. Lo and behold, that's 1 1/2. So with our rods, we can kind of visualize why that works. Now, we're not going to use the Cuisinart rods to do our division. That's just ridiculous, time-consuming, and not what we're after here. What we're after is nice, quick ways to multiply our fractions so that we get the right answers consistently. So let's look at some examples, and we're going to add our positive and negative numbers because we deal with integers and not just positive fractions. Okay, not integers, excuse me, integers are not fractions. We deal with real numbers that include negatives and not just positive fractions. So let's look at -5/8 divided by 3/16. You write the first number like it is, do the times, you flip the second fraction, not the first, but the second, times 16/3. Now this time I am going to do the reducing technique, which is to cancel before we multiply. Because if I multiply 5 times 16 and 8 times 3, going to get very large numbers. But I see that 8 divides into itself 1 time and 8 divides into 16 2 times, which will reduce my fraction before I even multiply. And as long as one number's on the top and one number's on the bottom, I can divide both the top and the bottom by the same value. Then I have negative 5 times 2, which is negative 10, over 1 times 3, which is 3. And since none of my numbers were mixed numbers, it's okay to leave my answer as a mixed answer, improper fraction, excuse me, and I don't need to write my answer as a mixed number. Ask your teacher for specifics. Your teacher, even on the test, will be glad to answer whether they want the answer as a mixed number or an improper fraction. Okay, let's look at the next example, negative 1/3 divided by negative 21. Notice this is a whole number. Whole numbers need to be written over 1 as we proceed. Then negative 1/3 is the first part. It's written like it is. The division is changed to multiplication, and we flip this fraction, 1 over negative 21. Then we see what we have. Oh no, I can't divide the 3 and the 21 like I wanted to here. I have to wait till I get over here. And when I do that, I see I have a negative 1 on top, and 3 times 21, a negative 63 on the bottom, which a negative divided by a negative gives me a positive 1 over 63. Okay, let's look at our last example, which contains a mixed number. Because it contains a mixed number, I want to change it into an improper fraction. 7 times 3 is 21. 21, 22, 23, 24, 25. Again, let's double check our arithmetic, especially since I'm on camera and don't want to make a mistake. 21, 22, 23, 24, 25 over 7. 21 plus 4 is 25. Then the divide changes to a multiplication, and we need to flip that fraction. 9 over 5. 5 goes into itself 1 time. 5 goes into 25 5 times. 5 times 9 is 45. 7 times 1 is 7. And because we started with a mixed number, generally, if you start with a mixed number, your teacher probably wants a mixed number as an answer. So 7 will divide into 45 6 times. 6 sevens are 42 with 3 left over. So that means I've got 6 wholes with 3 parts left over, and the size of my part stays the same. It always stays the 7. So that's 6 and 3 sevenths. Now, as I did these, there's also a video podcast on multiplying fractions. So there's some that you want to watch it as well. This was about division. But notice our procedure to multiply fractions involves 3 steps. Write the first fraction. Well, actually, excuse me, 4 steps because I didn't count right. Write the fraction. Change to multiplication. And I said first but didn't write the word first. Write the first fraction. Change to multiplication. Flip the second fraction. And then multiply. So those are the procedures. Now, why do we do division by multiplying by the reciprocal? That's what we've done, and that's what we've been taught. Write the fraction, change to multiplication, take the reciprocal, which I'm calling flip the second fraction here, or take the reciprocal of the second fraction if I want to be more official and more math-like. But why do we do that? Well, to end this, let me say this, and I found this as an expression, and it really kind of clicked as to why we do this. Why do we multiply by the reciprocal? Because division and multiplication are inverse properties of each other. And if you're taking our 700 course and you've gotten to the fraction portion of this, you've done solving equations, and we've talked about inverse operations and how addition and subtraction undo each other because they're inverse operations. And so, since division and multiplication are inverse operations, that's why, because if we change division into its inverse operation, we need to take the inverse or the reciprocal of that second number so that the operation is the same. That is why we flip the fraction, and that is why we do our division by changing it to multiplication and flipping the second fraction. I hope that helps. These are the steps, and that is their short lesson on division of fractions.